the many diverse uses of aggregates, road construction is of prime importance. Let's take a close look as to where from we get the aggregates. The quarries are one source and the riverbed another. The stones are collected from the sources. After collection, these are loaded and transported by carriers and unloaded at the site of work or the crushing plant. These are then broken manually or mechanically at the crusher. Bigger stones are fed into the crusher. And screened to segregate the crushed material into different sizes. The oversized aggregates are recirculated through the crusher and screens. The conveyor belt carries the crushed aggregate of a particular size to be stored in heaps. The aggregate used in road construction is invariably subjected to compressive load due to the action of the road roller during construction. Thereafter, during the service life of the road, the aggregate has to withstand the loads of the traffic. The most detrimental effect is produced by the bullock carts that induce higher compressive stresses on account of less wheel contact area. Unless the aggregate is strong enough to withstand the imposed loads, it will get crushed, resulting in damaged road surface. This leads to undulations, causing discomfort to the road users. The equipment for laboratory testing consists of test mold with base plate, tamping rod, measuring cylinder, weighing machine, sieves of specified aperture, the straight edge and the compression testing machine. The aggregate to be tested for crushing value is taken and sieved through 12.5 mm and 10 mm sieves. The material that passes 12.5 mm sieve but is retained on 10 mm sieve is selected for the test. The cylindrical measure is first weighed empty. The selected aggregate is filled into the measure up to 1/3 of its height. The sample is compacted by giving 25 gentle blows with the tamping rod. The tamping rod should be allowed to fall freely and not hammered into the aggregate. 2 more subsequent layers of aggregate are filled in the cylindrical measure in the same manner. The filled cylinder is flushed with the help of the straight edge. The weight of the aggregate is the difference between the filled and the empty cylindrical measure. This aggregate is then compacted in the test mold in the same manner as for the cylindrical measure. The plunger is placed on the aggregate in the test mold and transferred onto the platform of the testing machine. The test mold is adjusted for application of the load. The load is applied at the rate of 4 kilonewtons per minute. Till it reaches a value of 40 kilonewton, at which point the loading is stopped. The tested aggregate specimen is taken out. And sieved through 2.36 mm sieve. The fraction passing 2.36 mm sieve is weighed. The weight is expressed as a percentage of the initial weight of the test specimen. The mean of the two results to the nearest whole number gives the aggregate crushing value. A good quality aggregate to be used in the different layers should not have crushing value more than that specified for both the flexible and the rigid pavements. To sum up, the steps involved in the aggregate crushing value test are sieving for obtaining of test material, filling test mold with proper tamping, placing plunger in the mold and placing specimen on the test machine, loading up to 40 tons, removing test specimen, sieving through 2.36 mm sieve, weighing fraction passing 2.36 mm sieve, and computing aggregate crushing value. The aggregate crushing value should not generally be more than 30 to 45%.